Section 10.5, we're going to rationalize the denominator. Now, the reason we're going to do this is because the whole point of what we've been doing with all these square roots is to simplify them, get them as simple as possible. And in order to be simplified, we have to have no radicals in the denominator. That's just the rule. You know how mathematicians are and their rules. So no radicals in the denominator. In order to fix that, in order to get rid of the radicals in the denominator, we're going to multiply both the numerator and the denominator by the square root. So there's only one step. This is it. All right. So in order to get rid of a radical, you multiply it by itself, or in the case of a third root, you're going to have to multiply it by two of them. The whole point is to get a pair or a triple or get a group that you can bring out of the box so that you don't have a radical in your denominator. And you can't multiply the numerator or the denominator by whatever you want unless you multiply the numerator by the same thing. So here's the first one. Easy example. You've got 2 over the square root of 5. You can't have a square root in the denominator, but if you multiply the square root of 5 times the square root of 5, square root of 5 times the square root of 5 is just 5. So that gets rid of your square root in your denominator. In order to do this, you've got to multiply by the same thing on top and bottom. That multiplies it just by 1. All right? So now we end up with 2 square root of 5 over 5, and we're done. All right, same thing here. What we can do is split this up because it doesn't matter if there's a radical in the top, and we can't do 5 divided by 8. That's a decimal, and we don't want decimals and radicals together. That's just a big mess. So let's keep it square root of 5 over the square root of 8. A couple of different ways you can do this. You could split this up to see, well, how can we get a perfect square in there? Or you can just simply go the easy route and say, well, I know 8 times 8 is going to give me, square root of 8 times the square root of 8 is just going to give me 8. All right, so multiply the top by the square root of 8. And so now we have the square root of 5 times 8. So then we're going to take the 8 and say, well, that's 2 times 4, and 4 is 2 times 2. So we've got 5 times 2 times 2 times 2. And so we're going to take out a 2. So now we have 2 square root of 10 over 8, and then reduce that. So 1 and 4. So we simply have square root of 10 over 4, and we're finished. All right, as long as there's not a radical in the denominator, it's okay, and you're done. Now, what happens if you have a variable? Well, same thing. It's no problem at all. Square root of 2x, times the square root of 2x is just 2x. So you're going to multiply the top by the same thing. So your numerator is 3 times the square root of 2x, and you're finished. That's as far as you go because the 3 and the 2 won't reduce, and there is no x to reduce, so you're finished. Now be careful, be careful, be careful with all of these. It's going to be tempting to reduce something in the bottom with something that's in your radical on top. You can't do that because this is not an x, this is the square root of x. This is not 10, this is the square root of 10. So these are completely different numbers. This cannot reduce. Same thing here. 5 is not the same as the square root of 5. You can't reduce that. All right? All right, that's clear. Now, remember, if you've got a cube root, then your go fish number is 3. So you need 3 of something under that box in order to come out. So you have a 2. So if you have 2 more 2's, then that can come out just as 2. All right? So you're going to have to do the same thing in your numerator. So now when you multiply 3 times, oh my goodness, my handwriting today is horrendous. Okay, 3 cube root of 2 times 2 is 4. And once again, you cannot reduce these because this is in a cube root and this is a constant. 2 different numbers. All right? Okay, now what if I give you cube root of A and cube root of B? Now that's all sorts of craziness. Well, we don't care about the numerator. It can have anything it wants, but the denominator cannot have this radical. So in order to get rid of it, we need a cube root of B times another B. 1, 2, 3 of them so that they'll just come out as one set of b. All right, so we've got to multiply the numerator by the same thing. So when we multiply straight across, because these are both square or cube roots, it can go under the same box. So this is the cube root of a times b squared. Okay? All right. What if you have, and here, same thing, we're going to divvy this up. We can't take 5 divided by 9a squared, and so we can't do what's inside the box first, but we can split it up into two boxes and say cube root of 5 over cube root of 9 times a squared. Now, I'm going to simplify this down so that we can figure out what to multiply to get our perfect cube. So 9 is 3 times 3, and a is a times a. So in order to get our set of 3, our Go Fish number is 3, so we need 3 of them. 1, 2. We just need one more 3 and 1, 2, one more a. All right, and once we do that, we take out a set of 3 and we take out a set of a, and so 3a is our denominator, and that's fine. We can do that as long as we do the same thing to the numerator that we did here. We multiplied by cube root of 3a, so we need to multiply again by the cube root of 3a. This is already in a cube root, so it's all together under the cube root. So now we have 5 times 3 is 15a. And we're finished. All right? Okay, so what happens now if we have a fraction that looks like this? And you're going to say, no, say it's not so. Now, do you remember in the last section we talked about a conjugate? All right? The whole purpose of the conjugate is to make that middle term drop out. When we do that, if the middle term drops out, that means that all of the radicals will also drop out. If we simply multiply this denominator by the square root of 2, that'll make this part drop out. But remember, when you're multiplying by a binomial, you've got to multiply that by both parts. So then you're going to end up with 7 times the square root of 2. And it'll go back and forth, and you'll never get rid of it. So if you multiply by the conjugate, now remember the conjugate is the same term, square root of 2 and 7. There's a plus here, so there needs to be a minus in your conjugate. Multiply the top and the bottom by the same thing. All right, when you do that, now in your denominator, you're going to multiply the first terms and the last terms. You can multiply the outside and insides if you want, but I promise you, as long as you have the conjugate, your outsides and insides are always going to drop out. All right, so you don't even have to do that part. So the first terms are square root of 2 times the square root of 2 is just 2. And 7 times negative 7 is negative 49. All right, 7 times 7 is what? Yes, all of a sudden my brain went crazy. Okay, so now don't forget in your numerator, you've got to multiply this through. So you've got to multiply the 9 by both parts. Oh, and I can't, there we go. 9 times the square root of 2 is just 9 square root of 2. And 9 times 7, negative 7 is negative 63. So now we have 49, 48, 47, negative 47. And we have 9 square root of 2 minus 63. And it's okay to leave that negative in the denominator. If you're looking at the examples in your book, it'll show you how to move it up. And but that changes the numerator also. So just leave it in the denominator. It's totally fine. I will accept that, and it's the same value. All right. Next one, same thing. Okay. See if you can figure out the conjugate. Go. Did you get it? All right. The conjugate is the same. The conjugate is only, we only care about the bottom. All right, the bottom is where we want to get rid of the denominator, or the denominator, it is the denominator. We want to get rid of the radicals in the denominator. So the way to do that is to use the conjugate, which is the same terms, and this one is plus or minus, so this one needs to be plus. Same thing here. When you multiply your denominator, you're going to do first and last, because remember the outsides and insides cancel. So square root of 6 times the square root of 6 is just 6. Square root of 2 times the square root of 2 is just minus, not 2, or not 4, because it's the square root of 4. 2 times 2 is 4. The square root of 4 is just 2. All right. Your numerator is just a monomial times a binomial, so 2 square root of 3 times the square root of 6. Now be careful because this is going to be 2 square root of 3 times 6 is 2 times 3. All right, so we're going to get our 3 out. So 2 times 3 times the square root of 2. See where I got that? I just took this 2 square root of 3 times the square root of 6, and 6 is 2 times 3. I factored it to find that, oh, we do have a set of 3's, and so that can come out. All right, and now we're going to take 2 square root of 3 times 2, or not 2, but square root of 2, yikes, plus 2 on the outside, and square root of 3 times 2 is 6. So my final answer is 2 times 3 is, oh, here, let's put it right here. 6 square root of 2 plus 2 square root of 6. Oh, guess what? 6 minus 2 is 4. And now if you'll look, see all my squishiness? I'm going to finish it in red so you can see the final answer, because now I'm going to wrap around backwards and this is just not cool, but there's not enough room. All right, because all 3 of these are divisible by 2 and these are not inside my square roots, I can divide all 3 of those by 2. It's just like we split up each part and put it over 4. Remember when we did that? 6 square root of 2 over 4 plus 2 square root of 6 over 4. Remember when we did that? And so now this is going to be 3 and this is going to be 2 and this is going to be 1 and this one is going to be 2. And because these are the same, we can put them together, and I am going backwards. So then you're going to end up with 3 square root of 2 plus the square root of 6 all over 2, and there is your simplified answer. Ha ha! That was a little bit more than you bargained for, huh? All right, one more problem. Where did it go? One more. See if you can do this one a step ahead of me. All right. So simplifying, you want to rationalize the denominator. Remember that term. Rationalize the denominator means get rid of any radicals in your denominator. So this square root of 5. The only problem is it's mixed with this binomial. So you're going to have to multiply by the conjugate. I'm using all your vocabulary words today. The conjugate is square root of x plus 5. Because the terms are the same, signs are different. So you're going to multiply by square root of x plus 5 on top. So when you do that, your denominators, I don't know why I always start with the denominator. Maybe because it makes me know, oh yes, we did it right, we got rid of it. So x, square root of x times square root of x is just x. And then remember, we can just do the first and last and ignore the outside inside. Negative 5 times positive 5 is negative 25. The numerator is 6 times the square root of x, 6 square root of x, 6 times 5. And because this is an x and a 25, there's no way it'll combine, and there's nothing that can come out of those, so we are finished. All right? So sometimes it doesn't look quite finished, and it is, because there's nothing else you can do to it. All right? There we go. Simplifying, rationalizing the denominators. Make sure you multiply by the square root to get rid of it, or enough to make a perfect cube or fourth or whatever it is, or multiply by the conjugate. Easy sneezy. See you later.